Okay, get out of there. There we go. All right.
Do one more. Where you at? Turn that one back on. Try that on. That's all right. All right, guys. So this is page 150. Page 150. So do you see? This is the visual behind inequalities. Almost any problem that we do algebraically, there's a visual way to do it. Sort of like when we did substitution elimination, but we could also have done graph the two and see where they meet. You guys semi with me? So for a lot of mathematical problems, some that you wouldn't even think it's possible, you can translate it into a visual picture to work with directly. So here's my f of x, negative 1/2 x plus 2. Let's see, which one is that one? It's going to be the negative slope one, Jeff. There you go. And then, I guess that's g of x. F of x is the x minus 1. If I said, where does f of x equal g of x? Can somebody see that answer? Where's f equal g?
2, 1.
2. And the reason I don't care about the y, if I say, where does f of x equal g of x, what's the only variable that thing cares about? X. F of x equals g of x. So in general, you guys stay with me. In general, when it says where does something happen, that's an x. When it says what happens there, that's a y. That's an alpha. So where are these two equal? At 2. What can you tell me for x values below 2? If x is less than 2. What's true about f of x and g of x? Which one's bigger? So here's g of x, right? Here's g of x. And here's f of x. So for the x values below 2, who's bigger? G is bigger than f, right? F is smaller than g. Are you guys with me? So if this was the question, if the question was, become a pen, there you go. X minus 1 less than negative 1/2 x plus 2. Now, yes, I know we will solve this algebraically. Are you with me? But right now, how do I solve this geometrically where this line is below that line for x values less than 2? So what's the answer to this inequality? X less than 2. We're going to actually do that problem in a minute and actually verify that that's what we get. Are you guys with me at all?
Yes.
So that question, what's the visual interpretation of this question? This question says, when is that line below that line? You see how that's a beautiful kind of way to re-look at this problem? When is that line below that? Well, that line is below that line for x is below 2. X is below 2. Bam! Right? Now, is a graph always nice? No, that's why we have algebraic ways to do things. So like we said, find where they meet, but what if the answer is 7.782? I'm not going to do that graphically. There ain't no damn way. I can barely get whole number ones with the way my scale goes and all that shit. Oh, no. If it would have said greater than, then f is, of course, greater than g over there for x greater than 2. So for x less than 2, f is less than g. For x greater than 2, f is greater than g. For x equal to, they are equal to each other. Because that's the one point where they meet. I like it, maybe. So, turn the page. So now they ask me this question. See if you guys can figure out the answer to that. Just from the graph they get. Don't do any algebra to that. This is 151, should be, right?
Yeah.
You should be doing almost no writing. Right. This should be almost, you can just do the whole thing just looking at it. So this is 4x plus 7. They want that line to be over or under?
Yes.
Over. They want this line to be over this line. And of course, where does it start doing that?
-3.
At -3. So for x's that are, you do it.
Greater than or equal to.
Greater than or equal to -3, f is at least g. Why did the answer all of a sudden have the equal to option? Because I'm saying f can be greater than or equal to g. Well, here's where they're equal. And for x's above -3, f is bigger than g. I'm hoping you guys can see that. You guys see that? 4x% is a line. So I can just say, what is this line? 4x%. Bigger than or equal to this line. Well, it starts here and forever after. That's true. How do I know forever after? Because this guy's slope is much smaller than this guy. Ain't no way he's going to catch back up with him. I like it, man. So the answer to this problem, if we did it algebraically, should be x greater than or equal to -3. So let's take a minute and do those problems. Algebraic. Let's start with this one and do the other one. So we know already from the picture x greater than or equal to -3. How do I solve an inequality? There's only one difference from solving an equation. Have we talked about this before? I feel like we have. Do you guys remember this? Let me do it up here since I got it. Paper, there's. You guys remember this? Which one of these is bigger? 2. If I divide or multiply both sides by -1, which one's bigger now? What did the sign do? Flipped. We've talked about that before, right? I feel like we have. Okay. That's the only difference between solving an inequality versus solving an equation, is that. So here, what's the worst part about this? Fractions. How do I kill it? Oh, what's that? Why, Charles? So how do I kill that fraction? Yeah? Well, yeah, multiply everything by 3. So I get 12x plus 30 greater than or equal to 3's cancel here. So I get x minus 3. So if I just triple everything, I can kill that fraction. Now the rest of this shouldn't be too bad, right? There's no squares, thank God, because we don't even know how to handle that with inequalities. But subtract x, subtract 30, get x's on one side, numbers on the other one, and then I divide by 11. Do I flip the sign? Why do I not flip the sign? Because I divided by a positive. It's only if I divide by a negative or multiply by a negative. Not if there's a negative somewhere. We divided by positive 11. Does that match up with what we got? Yay! It's always nice. So the visual answer matched up with what we got algebraically. Kick ass. Okay, I like it.
I have a question.
Yes.
How do you know how to do this just by looking at it?
How do I know to do what?
Not automatically.
Oh, the problem would have to tell you. Here's the graph, right? So use the graph to solve the inequality. Is that what you're asking? You want to know how to do it this way?
Yeah.
They're going to tell you. They're going to say use the graph. And if you start messing with the inequality like we just did, you're not using the graph, right? So So they will be very obvious with which way they want you to do it. Okay, maybe. Okay, so that's kind of like the first part of this, is the graphical way to solve inequalities. The second part of section 8.1. Is there something, somehow this relates to bouncers at a bar. So, there's going to be an idea of and there's an idea of or. And is the mean bouncer. So, for example, you go into this bar, and the bouncers and the guy at the front door says, "I'm not just a bouncer, but he says, okay, to get in this bar, you got to know Joe, the bartender." I'm like, "I know Joe." And you got to dress nice. Oh shit. And you got to have a lot of money. Bye. Right? So if it's and, so for example, have you guys ever looked for scholarships? Have you guys ever looked for scholarships? If you haven't, I don't understand you. My God. Scholarships. Right? No, yes, no. So back in the day, before the internets, believe it or not, it was like the early 90s. I had to go to the financial aid office. There's this giant book of scholarships. And you open that sucker up and you're like, the student must be a math major. Check. Must have a GPA greater than this. Just barely. And then the very last thing they would say is, must be a woman. I'm like, why would you put that last? But it was ands, right? There, you must be this and this. So every statement decreased who was allowed to go for that. Just like the mean bouncer, and, it's going to decrease which people can go in. So when I say the word intersection, that's another way to say and. So what is in A and B? What's the intersection of those two things? They have to be in A and in B. So would 6 be an answer? It's only in this one, right? So which ones, of course, are in both? 1, 2, 3. That's it. So the answer, so this is what it would look like. There you are. So that's the symbol for it, right there. That means and. So A, it also means intersection. A intersect B, or A and B, would be the set 1, 2, 3. So if these were people's names, like, hey, I'm 1, hey, I'm -3. So who can get in the bar if these are the people that know Joe, and these are the people that have a lot of money, and the bouncer's like, you can only get in here if you know Joe, and you have a lot of money, these are the only people that can get in. So and will always decrease how big the answer is going to be, because it's restricting. Or is the nice bouncer. Or is the bouncer, I come up to the bar and he says, all right, to get in here, you got to be rich. Shit. You got to dress, or you got to dress nice. Shit. Or you got to know Joe. I know Joe. I'm in. Because he's or. So if I do any of them, I'm in. So let's look at a or problem. Don't worry, we're going to come back and do some more specific shit. Where's my or problem? Here we go. Page 153. It's also called the union, which is a really beautiful word for a couple reasons. It kind of makes sense. It unites the two things. It takes everybody from this one and this one, puts them together. That's what or does. And the symbol looks like from the word union. It looks like a U. I also love this symbol because, have you ever seen, like, when you're a little kid and your mom's like, I don't know, you or you, I don't know, somebody clean this room. You. Mix up you, shake. Somebody freaking clean the room. You. Maybe? All she wants is a clean room. So this is the nice bouncer. If you are in this one or this one, you get in. So you basically just list every freaking button. You don't have to list them twice. You're not going to say, who went to the bar? Well, Jeff did, and Jeff did. You already said freaking Jeff. This shit. So what's the answer going to be? It's going to be -4. It's going to be all these people. And who have I not listed yet who's here also? 4, 5, 6. So this is unites. That's why the name, the union as a name makes sense. It unites the two sets. Just don't list the stuff twice. You don't need to do that. Now 1, 2, 3 aren't special. See what I mean? I don't know if Jeff's talking from experience about the bar situation. All right.
Don't think about the horrible.
Yeah, the oral one doesn't happen as often, unfortunately, out in the real world. So let's go back and do some specific stuff with each. Now you kind of see the idea. Now this is, I want to kind of do this by itself. Can you guys find a blank piece of paper and can you graph this? Just on a number line, graph that. Now this is a little bit evil. Because what does this say? Read this out loud. What's it say? 5 greater than x. Which means x is less than 5. That's the better way to write it. So you shouldn't be going up, you should be going down. So here's 5. Where are my x is less than 5? This way. I like it. Bless you. We did talk about this earlier, right? Did the whole Dragon Ball thing, you guys remember? What symbol am I going to put on this? Yeah. So I'm going to put, sorry. I just watched the last thing of Super yesterday. There you go. Huh? No, actually, I watched it a little illegally, maybe. They haven't caught me yet, so what the hell? I'm on video. Shit.
Now you're on YouTube.
Yeah.
Come get me.
That's it. If I'm not here tomorrow. But the point I want to make is we're going to see something related to this, and people are going to misinterpret it. If the variable is on the right side, you don't want to look at it. You want to read it backwards. 5 greater than, x less than 5. Read it this way. So if, for example, I had something like this, -2 less than x less than or equal to 7. I always get people that do weird shit. They have like -2 and they shade down. No, stop it. What does it say? X has to do 2 things. X has to be, read it this way, greater than -2 and less than or equal to 7. I like it. So the best way to read this kind of thing is x has to be between -2 and 7. That's very direct. So when you go to graph this, what goes on the -2? Parenthesis, right? Because it's not allowed to equal. What goes on the 7? Bracket. And then you fill in the jam in the middle. So my bread and the jam. So yes, I will call this a sandwich situation. You see why? It's sandwiched in there. Yes, this is math, so it's yummy. A yummy sandwich is a sandwich. Sandwich. Okay. Let's get a little deeper into this. Let's do this one together. And then we'll go back and do this one. So, do you see how these are 2 separate statements, but they're brought together by an and? Take a minute and solve each one for n. Go ahead and do that first. They're both one-step problems, right? Okay. So the funny thing about and, so it's got to be, what's this one say? And has to be greater than or equal to negative 5. You have to read it this way because the variable's on the wrong side. Or you could just rewrite it reflection, right? You could write this as n greater or equal to negative 5. Reflected. Okay. So n greater than or equal to negative 5. So here's negative 5. It's got to be greater than or equal to that, but it also has to be less than or equal to negative 1. So see how that naturally leads to the sandwich ideas. So it's got to be greater than this, but can it go forever up? No, because it's also got to be less than that. So what's a better way? See how a better way to write these two is just to kind of join them together. Negative 5 has to be less than or equal to n. But what's got to be true about n? N has to be less than or equal to negative 1. So this is a much better way to write those and statements. Now let me give you an example of a problem that, let's see if you guys can see question. What's wrong with this? Everybody, let me leave that there for a second. So see, this is n between these two, and there you go. The picture makes total sense. Let me do the last step here. What would this look like in interval notation? Just going to do it. It goes from negative 5 up to negative 1. Include both of them, right? My poor little dude. There you go. Come on. All right. Now watch this. I'm going to show you a situation, a weird situation. Here we go. What if I said that 2 has to be less than x and x has to be less than 0? I'm sorry. Come on, Jeff. X has to be greater than, get out of there. X has to be less than, what's going to work? Yeah, that will work, Jeff. Yeah, you're silly. All right, sorry. I'm trying to make a certain thing happen. Do you guys see a problem with that? 2 has to be less than x. So x has to be bigger than 2. And x has to be less than 0. Can anybody give me any numbers that matches that? Because that whatever number you give me has to match both. And the minute it's greater than 2, it's definitely not negative, right? So the answer to this one would be like no solution, or even better. So if we put no solution on fine, but even better is this symbol. That symbol means empty set. So my answers are normally sets of numbers, like interval notation set of numbers, or just sets of numbers with a little squiggly. And they're in the set of numbers would be empty. That's the symbol we've given as 0 with a line through it. That means empty set. Here's the bucket of answers. It's empty. Yeah. Sorry. I always like that. Is there anything kind of amazing? All right. Let's go back up to this one real quick. And how do I solve this directly? Does anybody know? What would you do if that wasn't there? What would be your first step? Add 1 to both sides, right? So now we realize that that's a specific case. Add 1 to all sides. We normally only have 2 sides. But now we can generalize that. If I'm going to do something to the middle, I got to do it to this side and that side. So then you get -4 less or equal to 2x, less than 8. And again, what is it that's telling me what to do? The negative 4 and the 8 have nothing to do with what I'm going to do. It's the freaking 2. I don't want the 2 there. That's what's telling me what to do. You don't add 4. I mean, I get people. Do you understand why somebody might think, let me add 4? Because they think this side will disappear. But if I add 4, what do I get here? 0. That side doesn't disappear. They're like, I don't like all these sides. Let me kill one. You can't. Can't kill it. It'd just be a 0 there. So that doesn't make any sense. You're always trying to get your x by itself.
Yeah.
So divide by 2.
2,
So I get
-2, less than 2, x, plus 4.
All right, so go ahead and graph that and write it in interval notation. What time?
It's
Almost. Oh, so brackets are when it's allowed to equal. And when it's not allowed to equal, it's a parenthesis. So see how it's not allowed to equal 4, so it's a parenthesis. Yeah, this has an equal. So the really nice thing is, how do I determine if I put a bracket or a parenthesis? Well, when I see a hard line like that, I put a hard line like that. And when I don't see a hard line, I make it soft.
Oh,
And maybe put the jelly or the jam or whatever you want. Cheese, meat. I'm hungry. And then how do I write that in interval notation?
bracket -2, comma 4, parentheses.
I like it. Versus like just get to the answer. Alright. That's the answer. Cool. Let's see. Alright. See if they have any weirdness words. Yes. Let's try some of these. And we'll call it a day, I think. Let's try an OR problem. Take a minute and solve each one of these. They're their own separate thing. I got to get down to what A is, and then I can apply the OR to it. Bless you.
Thank you.
Oh, this is kind of evil. Let me see. Yeah. Okay. You started off with this one. All right. So if this was an and in the middle, a greater than -1 but less than 4, then that would be that sandwich like we just saw. But watch this. This is interesting. This is an OR. So a greater than -1 or a less than 4, less than or equal to 4, or takes anybody who is in either one. Is there anything that this leaves out? This is a little weird. So I need a number that's either greater than -1, or the number could be less than or equal to 4. Is there any number that doesn't do one of those two things? I love you guys. Think about it. Like, I don't know, -2 isn't bigger than -1, but it is less than 4, right? So all real numbers. So anything I shade at all for either piece, if it's an or, it gets included in the answer. So look, when I do all the shading, is there any part of the number line I left out? No, it's everything, right? Whereas if this was an and, here's a really good, so the visual to the and is this. Or the answer is going to be all real numbers. Because there isn't any real number that doesn't do one of those two things. I like it. If I said the only people that can come in here, they have to be older than 10 or younger than 20, and you're like, think about it, that's every freaking person, right? If you're not less than 20, you are older than 10, so shit. Right? You guys with me a little bit? No, watch. If this would have been and, look at why that name intersection is so beautiful. What is the intersection of this shading and that shading? The middle. That's why it's a sandwich, because and is intersection, which means they have to both be true. Or is either one could be true. That's why this little slightly freaky one ends up being all real numbers. It's like saying you gotta have more than $20 or less than $30 and you can come in. Okay, that's everybody. Yes.
So when writing your answer, when would you use how would you write it out with that symbol?
With interval notation.
No, with the symbols you said this means and this
Oh,
means
I see.
like I don't understand.
Well,
how
all
that's-
that the symbols would be they could instead of putting the word or they could have put a U there.
Oh, okay, so basically.
But they chose to put the English, which is nice.
Oh, okay.
Yeah. But what would this be in interval notation? It would be -infinity to infinity, right? For the or. For this problem, it would be all real numbers. I like it. So let me do a little a very direct problem here. So if I had x greater than -2 and x less than 5, greater than -2, less than 5, but it's an and. So where would the answer be? This stuff. And means the shading, where the shading overlaps. Where is that? Where did I shade this way and that way? Just in the middle there. That's the only place that is one and the other one. Now, what if it was this? X greater than 5 or x less than 1. So greater than 5 or less than 1. So that would be the answer. That's it. That's beautiful. So it can be greater than 5, so all those get included. Or, okay, we're going to include these people too, less than 1. So or is that guy's like, all right, yeah, come on, yeah. Maybe. So that's why I like to say and will almost always be a sandwich, right? It will be like this. Or will almost always be like this. And there's a problem coming up in section 8.3 where I relate this to a haunted house. Stay close to me. And I relate this to a restraining order. Stay the shit away from me. Right? So there are going to be certain types of inequalities with absolute values. Okay. I know we did some really freaky stuff today, but that's enough. We'll finish out chapter 8 tomorrow, I believe. We'll talk tomorrow about the next